have proved the isosceles triangle theorem, and now we need to prove its converse. Consider triangle ABC. We have been given that these two angles are congruent. This is all that is given to us. We're given that measure of angle B is equal to that of angle C. That's all. And what are we supposed to prove? We are supposed to prove that AC is equal to AB, which means the sides opposite them are also equal. You cannot take this as a rule, but generally, when we have to prove a pair of sides or a pair of angles equal, we look for congruent triangles and then use correspondence. But here, we see just one triangle, which is ABC. In such cases, we make two triangles. We can do a bit of construction too. Let's think of the different possibilities of how we can form two triangles. We can draw a line AD like this to form two triangles ABD and ACD. If we prove these two triangles congruent, sides AC and AB will be corresponding parts of congruent triangles, which in turn will also be equal. Now we come to the most crucial part of the video. What is this line? How and why do we draw it? Remember, this line which we use to form two triangles should be special in some way. It should help us to prove the congruence of these two triangles. By special, I mean it should either be the median or the angle bisector or perhaps the altitude. Let's try out the different possibilities. What if AD was the median? Then BD would be equal to CD. AD is the common side to both the triangles. And we have angle B equal to angle C. So it will be double SA, and double SA is not enough to prove the congruency between two triangles. So we cannot assume AD to be the median. Say AD is the angle bisector of angle A, which will make these two angles equal. In this case, we have two angles of triangle ABD equal to two corresponding angles of triangle ACD, and a side AD which is common to both triangles. It will be a case of AAS, which is surely a suitable condition for congruency. So we have basically drawn the angle bisector of angle A. Let's zoom out and understand the proof on the right-hand side of the board. The proof is really simple. Consider triangle ABD and triangle ACD. If we successfully prove these two triangles congruent, we can say that AC will be equal to AB. We know that angle B is equal to angle C. This is already given to us. Angle BAD is equal to angle CAD. We got this equation after our construction. And side AD is equal to side AD as it's the common side to both triangles. We clearly have a case of double AS. Triangle ABD is congruent to triangle ACD by double AS congruence. And we finally get AC equal to AB as they are corresponding sides of congruent triangles. We can write it as CSCTC. Corresponding sides of congruent triangles are congruent. If two angles in a triangle are equal, then the sides opposite them will also be equal. That's the converse of the isosceles triangle theorem.